Hello everybody, this is Dr. Christians. You're going to follow along with me in this video as we look at the Lab 10B post-lab, where we're going to be looking at taking some of the stuff that we've done and turning it into project costs. So follow me along through this video and we'll walk through how to sort of bid out projects or how to figure out how much things could cost. So we're going to walk through parts 0 through 2 together. So first what we're going to do is pull up this cost information spreadsheet. So I'll do that. This is, you can kind of think of it like our shopping list. So up at the top of the spreadsheet is the different types of items and how much we would expect them to cost. This is information that we've gathered with the help of contractors and past projects that we've accomplished here at Hope. A lot of these are in units of per square foot of area. So we need to know how big things are. Some, like these, are per square foot per inch of thickness. So if we do more insulation, we have to pay more for materials, so that's going to be more expensive. Down here at the bottom, things get a little bit complicated. This is rebates. So a lot of our energy saving initiatives are incentivized by our utilities. They want us to be able to use less so they don't have to spend quite as much on infrastructure. So we get 20% back, whether it's an insulation project or an air sealing project. If it's something that does insulation plus air sealing that doesn't double dip, we just get 20%. That's from the city, from Holland BPW, from our electric utility. So that's if our cottage has gone through the energy audit process by the city, and they have. So that's a really great incentive right off the top. Then from our natural gas utility, which is SEMCO, we have a number of different types of rebates depending on the type of project, whether it's attic insulation, floor insulation. These have some fairly, restrictive qualifications that we need to make sure we meet before we actually will get that incentive. So we have to make sure we meet these qualifications here at the right in order to be able to get these incentives. So to see how this works, we're going to walk through two projects fairly quickly. So the first project, project 1, we're going to look at determining the cost of adding an R10 basement foam board insulation to the walls of Schubert Cottage. So I'm going to go and simulate that quick. I'll go to my cottage energy analysis for Schubert Cottage. And I want to go to the basement, which is here, and add our 10 foam board. I want to see and think about the air changes per hour savings, but these are basement masonry walls, so I would actually expect not to see any savings for that. So we're just going to get the insulation R value here of R10. That makes a fairly modest change, but we'll see how much the project actually costs. The number that I'm really interested in is the size here, the 1,266 square feet. So we'll write that down for our first thing that we're going to record, which is the overall project size, 1,266 square feet. So again, I'm going to go through these bullet points. I won't write things down, but you should be. Then we're going to go to our cost spreadsheet and say, how much does basement wall insulation cost? We're going to scroll down the list and we'll see what we can find. Down here, 2-inch foam board, basement walls. That sounds like what we just did. That's R10 foam board installed over concrete walls. Great, that sounds just like our project. The cost is $5 and the units are per square foot of wall area. So we have 1,266 square feet. So our cost is $5 multiplied by 1,266 square feet. When you do that on your calculator, you get a total project cost of $6,330. That is our estimated project cost, but now we have to figure out our available rebates. So we'll scroll down to the rebate section, or if you have this printed out, which you might want to, this is just looking down at the rebate section. We're expecting to receive 20% on the project cost. This is an insulation project. from the city. So we take our total project, $6,330, 20% of that, so $1,266, we would receive as a rebate check from Holland BPW. Semco, we check our natural gas utility and see if they have any incentives. It looks like they do down here, line 38, basement wall insulation. So they offer a rebate of $300, but we have to make sure we qualify. So we'll look here on the right to see if we qualify, and it says we need to qualify, we need to improve an uninsulated base. So if we already had insulation there, we wouldn't qualify. We need to improve it from uninsulated to R10. That sounds like what we did. And we have to make sure that it was at least 250 square feet, which it was. It was 1,266. So it looks like we do qualify for that rebate as well, that $300. So our net project cost, this is the last thing that we need to determine. This is what we would actually budget. It's $6,330. That's what the contractor is going to charge us, or we expect the contractor to charge us, somewhere around that $6,000. But we expect to receive about $1,266 from the city and another $300 from our natural gas utility as incentives for accomplishing that project. So we expect the net cost to be around $4,764. So how are we going to record all this? Well, we can go to our recording spreadsheet, and we probably want to make a new column. So this is the basement wall insulation. I've added these values and added our predicted savings. I'm going to add 2 more columns here, right? Lots of columns. This is expected costs, and this is ROI, which has units of years. So our expected cost, this was $5 times 1266 minus 0.2, 20% times our cost, 5 times 1266, and then minus another $300 from our Semco incentive. So this is our expected cost. Our rebate, or our return on investment is going to equal this cost divided by our savings per year. We don't know quite what our savings per year is going to be. Maybe on the low end, $13, on the high end, $24, $25. But to get sort of a sense of that, I'm just going to choose the middle number, and we'll see this is not years, this is now a number here. So I'll change this to a number. We would expect that project to be almost 300 years to pay back. And that's because in Schubert, this doesn't give us a whole lot of extra savings, but it is quite a big area and is going to cost a fairly significant amount. All right, let's do one more project to kind of get the hang of it. So if we go back and we look, our second project is going to look at attic spray foam. So when we're installing spray foam, we have to think through a little bit how the project is going to go. So we can't just put spray foam very well on top of existing insulation. What we actually need to do is take a big vacuum and suck out the existing insulation, and then we're able to put spray foam down. So let's go first simulate this. So we can go to simulation 2. We're going to simulate 6 inches of spray foam. So that was going to take this both to R36, but it is also going to have a pretty significant weather sealing advantage. So spray foam blocks little cracks and holes very well. So this is going to work quite nicely to improve the leakiness of our home. So this is about an 11-12% reduction in energy, which seems pretty good for one project, but we'll see how much the project costs. So we go to our shopping list, and we check here. We can see here's some different things that we could do from the attic. We see attic insulation removal. This is necessary prior to applying spray foam, as I said. And this is attic spray foam. This is a per inch of thickness cost. So if we're doing 6 inches, we're going to need to make sure we account for that 6 inches of thickness. All right, these are both, we need to know the size of our attic areas. So I'm going to go back and say, okay, how big was the attic space? There were 2 separate ones, so we need to add these together. And that gets us 1,451 square feet. So 1,451 square feet, that's our total attic area. Now we can go and figure out how much it cost us to remove the insulation. $1,451 approximately, around $1,500 if we bid that out to a contractor. So we would expect to see. And then we have 6 inches of insulation. So we'll go back and say, well, each inch we expect to be $2.25. So $2.25 times 6, so $13.50 per square foot. That's quite a bit. So I need to take $13.50 plus an extra $1 to account for the removal costs. And I would expect this total project to be $14.50 per square foot. So when I multiply that by the square footage of my attic, I expect this to be about $21,000. So let's go to our data recording spreadsheet and record our math. So I now have this expected costs column here. So this is where I'll do my math. So this is 1451, that's our area, multiplied by $1. That's how much it takes to remove the existing insulation, plus 2.25 times, not 21.25, 2.25 times 6 for 6 inches. So this is my expected project cost, around $20,000, but I'm not done yet. I have some incentives. There are some rebates that I think I'm going to be able to qualify for. So let's double check to see what those could be. So now I have the overall cost that the contractor is going to charge, or what we think the contractor is going to charge. Let's find our rebates. So we expect a 20% rebate from the city. That's great. Attic insulation. So if we improve an R19 up to an R30, which we did, we would expect $400 in rebate per residence. So that's going to be good. That's our rebate. That's the only one we get. We can't qualify for multiple of these. We can qualify for only one. If we improved the R value more, say to R60, we would qualify for a little bit higher rebate, but we didn't do that. So we expect this $400. So let's go back to our sheet. So what I can do is to calculate the 20% savings, I'll just take this and multiply it by 0.8. So this is the expected cost after that city rebate. And then I also have $400, so I'll subtract off $400. Again, if you don't want to do it all in Excel, you're welcome to do it pen and paper. That might be a good way to limit mistakes. But here I expect this to be about a $16,000 project. I'm going to calculate the ROI. And actually, I already have this formatted, so I can just click this little box and drag it down. And this I expect to be about an 80-year ROI. So it's a significantly more expensive project, but also saves significantly more money. So maybe around $200 a year. Still not a very good ROI project, and actually the budget is going to be higher than the total budget for the total project that we have to work with. So probably neither of these are going to be great projects for us. What you're going to do now is go and simulate some additional ones, and hopefully you can find some that are a little bit more promising. You're going to look at first some windows, a window replacement at Schubert. You'll do the same things that we just did. And then you're going to look at a project of your choice, but you're going to choose one that you've already simulated. So hopefully you already have most of it already done.